those of you who are new to me as an instructor, I have several students in here that know me. Sir, what's your last name again? Pena. All right. So, John, right? John? DeMarc, I get you two mixed. Okay, so, Mark number 16. Here, this is you. Please remember your number that I gave you on that clicker. Please remember that. Every time you come into class, these clickers are going to be sitting up here. Your job is to come grab your clicker, all right? Just yours. Nobody else's, all right? I'll show you how they're going to work. I'll get back to what I was saying about students who already know me. Sir, what's your name? Duncan. Duncan, all right. You're here. Grab this here. You're number 2 on this little clicker. Don't forget your number. Sir, what? Oh. What's your last name again? Yep. Okay, number 9. Here you go. Okay, so let me explain what these little clickers are. This is new. My students who even had me, this is like my new little thing this semester. What I'm going to be doing is this. Just wait. I'll be coming into class. I'll be bringing up my roster. This. Let's see who just came in. Okay. Alexandra, where are you? You're number 6 over there. See number 6. Demekus, you are number 10. Grab number 10. Tim, you're number 21. You need to grab a little clicker over here. It's a number 21 on it. Okay. Everybody has a clicker? Okay, so the way it's going to work, you come into class, you grab your clicker, right? All right, now, taking attendance. If you're here, press number 1. Everybody good? 22 students here. 23. Everyone's pressed number 1. You can press it more than once. It's not going to mess it up. It's not going to count it. Okay. So that's it right there. That's who's here and who's not here. All right? Now, if you came in and you weren't on my roster, 27 and number 28, right? I'll fix it so your name will appear there. Did you click your clicker number 1? You clicked it for him? Okay. All right. Got the idea? So that's attendance. And then the next thing we'll do is like something like, I don't know. Just imagine I'm sitting up here and we're talking about something and we want to find, we have like a function, let's say function of x, y, and z, right? And better yet, I'll make it a little more complicated. I'll make it a vector field. We have a vector field, right? And then what we're going to do is we're going to take like the unit sphere and we're going to compute the flux on the sphere, right? So we have the formula for flux, right? Yes? Do you understand? If you understand, press 1. If you don't understand, press 2. Okay, so you get the idea? The point of this is that a lot of times, at least in the beginning of the semester, it's kind of a challenge to get people to actually give me their honest opinion here. And, you know, you just sit there and go, shit, I don't want to be the only person who's like raising my hand. And what I'm going to look for is an 80% green, okay? If we got an 80% of the class is good with it, we proceed. If it's less than 80, then we need to talk. But that means people are going to have to ask questions. So, understand? Now, I don't know if we'll keep this the whole semester. It just depends. If I can get you all talking, then I don't have to do this necessarily. All right? There's nothing worse than me being up here trying to help you learn something, and then you're not willing to ask questions. If you're not willing to ask questions, then I can't do anything other than just, regurgitate information for you. So hopefully this will be kind of a no risk sort of response thing, all right? And I'm not going to track you or anything. Like, I'm not going to go back and say, okay, this student said no like every single time. I can do that. I mean, like, it's gonna record everything like that, but I'm not going to ever go back to it and be like calling you up saying, you keep on saying no, like, come into my office for help. That's on you, okay? If you're saying no to everything and you're in that 20% that keeps saying no, then you've got to reach out for help. Okay, so we'll see how that works. It's a work in progress. Don't know if I'm going to wind up just not doing it at all. Hopefully you're familiar with our website for the class. Oh, and the students who've had me before, what I was saying earlier, can explain what all this shit is up here, right? Sorry, I tend to cuss unintentionally. So what am I doing? Guys, girls, ladies? I'm recording all this, right? So everything that appears up here, everything I'm saying is going to be on YouTube later today. You can go back and watch it, all right? I still don't know. I've been doing it for years. I don't know if it's beneficial or not. I mean, some students really say they like it, and then others. But I can tell you right now, I haven't seen a difference as far as grades. Like, when I started doing it, it wasn't like all of a sudden, boom, like everyone's doing well now. So I haven't yet, like, given it up yet. I probably will once I get a good library of videos. I want, like, 5 semesters worth for each class, and then I'll just tell my class, hey, I've got a bunch of YouTube videos, go watch them if you want. But for now, that's what this is about. Okay, so go to Northwest Vista's website if it opens. Yeah, I already clicked on it. It's just sitting here, doesn't know what to do. Had a feeling this would happen. Let me see if I can remember this. www.instructure. Might be the other way around. Come on. Shit. All right. Well, the web was working earlier. I don't know what the hell's wrong with it now. Everyone's trying to get on. Well, same thing happened yesterday, but all morning it was working okay for me. Well, what I was going to do is I was going to bring up our website for the class, which I know at least 14 of you have been to. It shows me who's been there, who hasn't. There's a good, like, 8 students here who haven't been on Canvas at all. So if you have no idea what I'm talking about, when I say that you need to go to Canvas and log into our course to find the syllabus and everything else, if you have no idea what I'm talking about, please just talk to me after class. We'll find a way. I have a back door into the system. I just don't have the website with me. Actually, it's on my phone. Can I not do that, though? I don't want to have to go through all that. Is that all right? Yeah? Okay. So on that website, though, you'll find the syllabus. There's an orientation video that I want you to watch that explains, how things are going to work in the class. I sent you, I think, 2 or 3 emails. One of them was to go to a survey, this website called Doodle, where you're supposed to fill out when you can study, like when you plan on studying for this class. And I had, I think, 14 participants. What I want you to do, I'm going to hand this out. This is not the final version. Once everyone has participated in that survey, then I will hand out a final version of this, but I wanted you to see what I plan on doing with it. So let me just pass these out, and then we can talk about it. So just take one, pass that. What I was asking for is for you to look Monday through Sunday, every day of the week from 6 a.m. to 11 p.m. to fill out when you plan on studying for this class. And what I'm hoping to do is get everybody in the class's schedule And so that what you can do is you can look across and start to find students in this class that have similar study schedules to you, and then maybe you can start forming your own groups and be like, hey, you know, I'll give you an example once everyone has these. Again, this is only the 14 students who have filled this out. Are there enough copies? So, for example, if I'm Ernest Ortiz, right, on Mondays, looks like at 1 o'clock, which is after this class, there's, 11 students that can all get together, for what they're saying, they can all get together and study after this class. And then it looks like there's 9 students that can stay even from 2 to 3, and then 10 students that can go from 3 to 4. So, I mean, that's a good chunk of the class that looks like they're free right after this class. Now, that's of the 14 students that have filled out the survey, all right? All the students who filled out this survey before, when was it? There was a deadline. Was it Monday at 5 o'clock? This counts as a quiz grade. Everyone who did it Monday by 5 o'clock got 110 on this quiz. You have to do this by next class. I think I said by Friday, but I want you to have this done by next class, and not like 10 minutes before class. If you could do it like maybe tomorrow, by tomorrow, that way I can consolidate all the information and then hand a new one out to you on what? Oh wait, hold on. I'm all off because of the holiday. Do it by Friday, and then by Monday I'll have a fresh one. It should have every student across the top. All right, that makes sense? If you're like, I don't want people to know my schedule, this is bullshit, I don't like this, then just at least go in there and don't check anything. I don't care, but you know, submit something so I can give you a grade. If it's not done by Friday, it's a 0. Okay, so this is an easy 100 on a quiz, right? All right, so that's the first email I sent. The second email that I sent had to do with getting to know a little bit about you. And so it took you to SurveyMonkey. Let's see if SurveyMonkey comes up. Yeah, the Northwest Vista website's down. So SurveyMonkey, I asked you to fill out a survey. I've had 14 respondents, so it looks like nobody knew. This is optional, okay? This is an optional thing, but I would like to know a little bit about you, a little bit about your background. I'm showing just a few of the questions. I don't want to show everything because some of the information is personal. But I want you to get an idea of what you're working with here, like your classmates. Okay, so the first question I asked is, how many hours do you work a week? Let me try to make this a little bit bigger. So it looks like we've got, somebody doesn't work, 19 to 40 hours, nothing, 30, nothing, nothing, 30, 50, 50 plus, 30, 20, 28, okay, 40 to 50. So this is difficult to kind of come to any conclusion here, but my advice would be that, you know, if you're working 40 to 50 hours a week, then I'm hoping this is like maybe one class you're taking, maybe 2. But if you're doing the 40 to 50 hours of work, you're taking full-time load, then in order for you to succeed, you're going to have to be in like the top 0.5% of students that I've ever had in my life. Like, there are not many students who can balance 40 to 50 hours a week and then take Calculus 2 and other courses. It's just not, reasonable, right? It's for the same reason that you can't get a degree in engineering in one semester, right? There's a limit to how much a human being can absorb, right? So if you have too much on your plate, you have to do a little self-reflection. If you have to keep the job, then you have to slow down the courses. You just can't take as much. All right? So I mean, I'm just giving you my advice, my experience. Okay, what I've seen. I get students that come in, they struggle in calculus, and then I talk to them face to face. I'm like, how many hours are you working? 40. How many classes are you taking? 15 hours. Physics, blah blah blah, chemistry, and I'm like, what do you expect? You don't have the time. So this is a time-intensive course. All right, this one, okay, is very time-intensive. How many hours a week do you have to study for all your classes? Again, this depends on how many classes the student's taking. As much as it takes, 20 or more maybe. This is all good. 60, 20, again, that's That's not bad. If you're working, if you're doing a full-time load, that's okay. 16, 10, as many as it takes. 20, 35 plus, 10. Hope you're not taking a full-time load. 30, as many as need. Oops. So that was it for that. So it looks to me like students have enough time. I mean, my guess is to do it right, if you want to be an A student, you're going to need 4 to 5 hours per week for this class, outside of class. All right? And I'm serious. That means to do your homework, because it should take you that much time if you do it properly, and you should always do more than what I ask, right? If I ask you to do all the odds, you should do the odds and the evens, right? Okay, what's your major? So get an idea of who's in here. It's almost all engineering. Computer science, engineering, math, mechanical engineering. There's a pre-farm here. Can I call this person out? Whoever this is, you want to volunteer yourself to identify yourself? So is pre-farm requiring Cal 2 now?
I think it's
Mm-hmm. What I'm finding now is a lot of these medical fields at the major universities like UT Austin, Texas A&M, you want to be a biology major, you need Cal 2 now. You're going to go pre-farm Cal 2. And I'll tell you why I think that's the case, all right? If you ever want to weed out an applicant pool, right, you raise the math standard, that's an automatic weed out, right, isn't it? And then there's another thing that I think is a little more subtle. Somebody who's a biology major or maybe pre-farm or something like that may not love math. Okay, you may not be in love with this subject. It may not be the same thing as studying, anatomy and physiology or something like that. However, what they're doing is they're saying, look, a student who can get through Cal 2 demonstrates motivation. All right, they're motivated to learn something even though they don't really care for it. And they may not even have been good at it, but they've demonstrated they could figure it out. And that's what they're looking for. If you're not willing to get motivated for this and you're like, I hate math, but I want to be a biology major and I don't know why they have Cal 2. If you can't get motivated for it, they don't want you. That's basically what the story is. All right? So you're going to have to find it within you to enjoy it. Now, when I say that, I asked this question last math class. We won't look at that. I don't think well, this was good. How many of you, do you enjoy math, yes or no, or sometimes? This is better than my Cal 1. My Cal 1 was about 50-50 when I did the survey on them yesterday. So this is a good percentage. Now remember, this is only 14 out of all of you here, so I don't know how accurate this data is yet. So please take some time, 10, 15 minutes of your life to go fill out these 2 surveys for me. That way I have a little bit better idea who you are. You come to visit me in my office during office hours, I'll probably pull the survey up and I'll talk to you and we'll go through this. And I'll just kind of know who you are a little bit. All right? Any questions at this point? Sure? Everything in the syllabus is laid out as far as exams and all that. Yes? I do not grade homework. No. Well, let me just say this. If you don't do your homework, you're not going to pass this class. It's very simple. This is not Calculus 1, all right? If you got through Cal 1 without doing your homework and you've never seen Cal 2 and you think you're not going to do your homework, go ahead. It'll just be there'll be more seats later, okay? I'm not here to I'm not trying to threaten you. You can do this subject, okay? Cal 2 is achievable, all right? A lot of people get through Cal 2. It requires a lot of effort to do it, which again is time management, things like that. But I'm not here to crack a whip on you and be like, let me see your homework. I want to make sure you're doing what you're supposed to be doing. This is college, okay? It's your education. It's your goal. It's what you want to do. If you can't find it in you to go home and do your homework, then it's all just talk. I want to be an engineer, but I don't want to do the work. Okay? So, all right. Hope I'm not coming across as an asshole, but I want all of you to succeed, okay? I mean, Cal 2, is probably the biggest hurdle that you'll face in the calculus sequence. Cal 3, a lot of people say, is easier. But then after this, you get a lot of the engineers we have here, get into engineering analysis, and that's even harder than this. So it all keeps getting more difficult. So you don't want to, if you're an engineering major, you don't want to go through this course and just scrape by with a C. And you want to be top, not top of the class. I mean, everybody in here can get an A. I'm not going to give a test and be like, too many of you got A's. I'm going to curve it down so that I get more C's. I basically give the same material on every test every semester for the past forever years. So the material hasn't changed, right? Okay, survey done. Any other questions about that? I was asked in my other class about makeup tests. Like, do you allow makeup tests? Again, no. I mean, it's just one of those things that, the time to perform on a test, that date, that time, that's when you need to have known that material. It's not like, okay, he's going to let us replace our lowest grade with the final. I don't want you to go into this thinking that. That first test is the most important test for you. After it's over, then the next one's the most important thing, and that's the way you go through. It's like a job, right? Your boss doesn't come in and say, hey, look, you need to do this, and you're like, well, but if I screw it up, can I get like another chance later to do it better? Or just that's not the way the world works. So I don't want to sugarcoat anything for you. What else? Anything you have? Was it wrong? Oh, yeah, I probably did. Yeah. It didn't have spring break in there? Yeah, let me see my printed one here. No, we're not having spring break. I'm sorry. No. No, the one I have in here is printed out, so it has spring break in there. So we're going to have 3 exams. Again, this is all in the syllabus, but our first exam is on February 23rd. And that's when it's scheduled, okay? Any of that can change. We can push it. I don't normally make it the exam like earlier than it was supposed to be. But our goal is to cover everything that's on that calendar, which is a lot of material. All right, so I'm ready to start unless you have anything else that you want to talk about. What are the grades? Quizzes? Yeah. I don't remember the breakdown because I don't have it. Let me try one more time to see if I can get in here. Oh, okay, good. There's a syllabus confirmation quiz, I believe you have to take, and it's in Canvas, and it's due on Friday. And all you do is you click on it, and it just says, I've read the syllabus, I understand the requirements of the course, yes or no. And that's the way that, if we come to a point later on the semester and you're like, well, I didn't know, then I can go back to that quiz and say, you said you knew. So it's my way of just saying you did read the syllabus. But, of course, if you can't open up Northwest Vista's website, then I don't know how you can do much of anything, right? All right. So let's get started. So someone said 5% said that they knew how to compute flux, which means that they may be back here. I had a student last semester in Cal 2 who is already an electrical engineer, had just come back to take Cal 2 just for, I don't know what. But so it happens sometimes where you're sitting there and the person next to you knows all this already, and they're like, they seem like a mad genius, but they've already seen us all. So, yes. What's up? Just hanging out. All right. You're here for the class, right? Well, you want a chair? There's a chair right here. You squeeze in somewhere over there. What's your name? Brandon. Brendan. Brendan, you're number 7, okay? And that you need to remember that every time you come in here, you grab that number 7 clicker. All right, so one of the challenges that I have as an instructor sometimes, and I'm speaking to a few students in here that I know have taken Cal 2 before, all right, and that are retaking it. Is that it's hard when you've seen the material to you can become a little complacent, like, okay, I know this and stuff. So, but what I'm asking is for those students who have seen Cal 2 before, you know, when we get to a point where it's like that's where things started to not click, you need to make sure you engage me and ask for help. All right. All right. So let's talk a little bit about Calculus 1 and what the major results of Cal 1 were. And I thought I'd ask you. So what were when you came out of Cal 1, what were the main things you took away from it? Derivatives, okay. Derivatives, yeah. Limits, we loved the limits, didn't we? So it was actually, in calculus, it was the reverse order, right? You learn the limits first, and then after the limits, you learn the derivative. And then you get all upset because they give you the rules, and then you're like, well, why didn't you just give me the rules to begin with, right? And the reason why is because the limit is actually, if you look at like not a graph, but like a visual representation of calculus, limit is at the center of it. And then all the different branches come off of the limit. So you have Cal 1, you've got Cal 2, you've got differential equations. All these different branches of mathematics are all based on this idea of the limit. So if you were to take a course like business calculus, then they just very quickly say, here's the limit, and then they just kind of like, okay, here are the rules. They don't really push into the limit very hard because they know you're not going to be doing all this other stuff. In Cal 1, we have to talk about the limit. We have to get you thinking that way because in Cal 2, you're going to be doing a limit again. And then further on in Cal 3, you know, everything is based off of that idea of letting something approach something without actually being there, right? Or letting x go to infinity. So it's a concept. All right, what else about Cal 1? Related rates. So give me an example of a related rate problem. Just like what did they sound like? Okay, that was optimization. That's optimization. Yeah. Okay, curve sketching. Integration. Which integration is kind of tied into antiderivatives, right? So integration and antiderivatives is usually at the end of the semester, and depending on how your Cal 1 class went, you may have seen this, you may have not seen it, you may have seen a lot of it, you may have seen very little of it. It just depends, all right? I know for my Cal 1 class that I did last semester, we did get into antiderivatives a little bit. We didn't get too heavy into it. You know, curve sketching, optimization, related rates, those were nasty. Limits, derivatives. How about just visually, what did the derivative give you? Like if you were talking about the derivative, is what? Slope of tangent line, right? So if we have a function in Cal 1 like this, then if we say take the derivative, then we're saying you go to a certain point on this graph, right? That's some value, I'll call it A. And then if you look at the slope of the tangent line there, the slope is actually f prime of A, the derivative of the function evaluated at that A. Yes? And what that allowed us to do is actually find highest and lowest points on the graph, right? Because we could say, well, when's the derivative 0? Or if we had like a cusp, if our function did like this, that little cusp there, then we would know that the derivative was undefined there, so we'd look at those points also. We had different methods for finding max and mins. Closed interval method, open interval methods. So a lot of this study that we did in Cal 1 was all two-dimensional. It was all on a flat sheet of paper, It was a function, and we were looking at the behavior of the function. So in Cal 2, we're gonna step away from that, and we're gonna do something a little different. Visually in Cal 2, we're gonna do a lot of reverse process of derivatives. So when we took a derivative, start with the function, right? We take its derivative, right? And we get something, a new function usually, right? And so that's what Cal 1 was about. In the beginning of Cal 2, we're going to be doing the backwards process, antiderivative, which would go this direction. So we still start with the function. We go backwards to find its antiderivative. And once we spend the first, we're going to spend the first all the way until your first test. Everything on your first test is going to be antiderivatives. Just practicing this operation of going backwards, all right? Then after that first test, we get into the applications. So what we can do with it, all right? So in the beginning, there's not going to be a whole lot of visual of like why we're doing it. It won't come till later, all right? So after we spend a couple of weeks on this antiderivative process, then we get into things like, all right, well now let's see what we do. We have a function, and let's just say, for example, this is time, and let's say this is distance, or no, we'll do it this way, velocity. Okay, so let's say you have an object that's moving, and you know at every point in time, you know its speed, its velocity, right? So at, this point in time, you know its speed. This point in time, you know its speed. Then this is just a Cal 1 thing. What would the derivative of this function represent then? The acceleration. Because this is a velocity curve, isn't it? A velocity function. The derivative of a velocity function is an acceleration function. So the derivative of this is acceleration. However, the antiderivative, the backwards process, would be something else, right? It would go back from velocity, should take you where? To the distance, like the displacement function. Well, what we're going to learn is that if we can somehow find the actual geometric area under that curve, geometrically that area, that measurement will represent our total displacement. And then if you change the values of these two things here, your independent variables, then you can get things like, if you have like force and distance in here, force times distance is work from physics. So if you look at this, and this will give you like total work done. So it's geometric, okay, area under a curve, but then it can be tied to many physical situations too. Chemistry, physics, biology. The area under a curve represents something. But in a math class, it's just, can you find it? And then later you do the application. You can also do something like take two curves, all right, and tell me where, imagine that this is like some sheet. Maybe it's a sheet of aluminum or something like that. Tell me where its center of mass is. All right? That's something that we'll be able to do in this class. Find the center of mass of some two-dimensional flat we call them a lamina. All right? But to do it, we're going to need antiderivatives. We're going to need to be able to go backwards in that derivative process. And then you can go even crazier than that. You can say, imagine that this sheet is what we call non-homogeneous, which means that, like if you talk about a homogeneous lamina, you take this sheet of paper, we can kind of assume that the density of this paper is the same throughout. So if I take it and cut it in half and weigh both of them, they should weigh the same. Close, right? Close enough. I mean, they can't be exactly the same, right? Because they're little fibers of wood and stuff. But we can say for the most part, this is homogeneous. Now imagine you have a lamina that's not homogeneous, that its density varies throughout the lamina. can you still find the center of mass? Yes, you can. But you have to have that antiderivative process before you can do it. All right? Then you'll do things like this. Instead of looking at this like a lamina and you want to find center of mass, imagine you take that two-dimensional sheet and take this whole two-dimensional sheet out of the paper and just revolve it around the x-axis. Right? Give me just a second. I'll show you what I mean. I use Mathematica for my visualizations. So here's just imagine you have a curve, right? And what we're going to do is we're going to imagine taking like a sliver of that curve, right? Just a little rectangle that goes up that curve. And we're going to imagine we're going to rotate it around the x-axis. Now, can you tell what that looks like? Well, how about I pop this out of two-dimensional space and now rotate it. Do you see what I'm talking about now? You get the idea here? It makes like this wafer-looking thing, right? And that wafer has a volume to it, doesn't it? And so what we want to know is if you take the entire curve and rotate it around the x-axis, what's the volume of the entire thing? That'd be like almost like a football shape, wouldn't it? It would look like this. What's the volume of that? And then we might want to know what its surface area is. Okay? We can do all that, but we need the antiderivative process before we can do it. What else? I think that's good for some of the applications. And then we get to series, chapter 8. And that's where it becomes pretty challenging, all right? I think, I mean, I don't know. Some people who've taken it before, they do well with series. Other people, they don't. I think that the two hardest parts of this class, the front end where you're learning all the antiderivative stuff, that's usually the hardest, one of the two hard parts. The middle is usually okay, all this solid revolution stuff thing. And then the end, the series, that's again another hard part. But I usually think if you can get through the first part, by the time you get to series, hopefully you've matured and grown enough in this course where you're ready for it, all right? So series is something like taking this concept. If we fill up a cup, let's say we had some way of building a cup that held exactly, we'll just say 1 cup. So this is like a perfect container. It holds exactly 1 cup in it, all right? It's empty right now. So if I come in here and I say, I would like for you to pour into this cup, right? Let's pour into that half a cup, all right? So pour it, you imagine it filling up halfway, right? Now what I want you to do is I want you to pour in 1/3 of a cup on top of the 1/2, right? And then after that, I want you to pour in 1/4 of a cup, and then 1/5 of a cup. And you keep doing that, and I don't want you to ever stop. The question is, will it overfill? What do you think? No? Yes? No? Oh, let's do a vote. On your little devices, how many of you think that this will overfill? Yes, it will overfill, 1. No, it won't, 2. And I'm waiting till I get 26 responses. Okay, so everyone in? You can change your answer, but just don't change it after I tell you the answer, right? Okay, so we've got about 2/3 of the view think it won't overfill, and then you've got the other that think it will, it won't, right? Okay. This is going to overfill. All right? Now let's talk about why. Okay, if I put in half a cup, okay, half a cup, it's half full, right? And then if I bring in these two fractions together, let's just add those two fractions, all right? I don't know, however you add fractions, common denominator, whatever floats your boat there, you get 7/12, right? If you add those two together. 7/12 is bigger than 6/12, isn't it? And 6/12 is 1/2. So you've already overfilled the cup because you've done a half plus a half, and now it's over full, right? So just because these were getting smaller did not mean that it would actually be finite, right? They got smaller, but it was still finite. Can you change your answer? Thank you. Now, so a different question now. What if I did 1/2 plus 1/4 plus 1/8 plus 1/16, and I did that forever? Would that overfill? Yes or no? Go ahead. Yeah, we're done? So this one, it will not overfill, right? That it won't. Now I can't show you right now because we have to start talking about that when we get to chapter 8. But this one won't overfill. Both of these have similar characteristics. As you look at these, they are getting smaller and smaller and smaller. We're adding them up forever, but it's not finite. It becomes infinite. Okay, this one, they're each getting smaller and smaller, and you're adding them up forever, but they get small fast enough so that it is finite. It actually does not overfill the container. It actually converges to a number, and we'll figure out what that is. This right here is what series, at least the beginning of series, is about. It's a series of numbers being added together. So we want to know how they behave. And then after that, you realize that, or we investigate the fact that any function that you can come up with that's continuous, all right? Continuous, well-behaved function can be approximated by what we call a power series, which means if I take any function, it doesn't matter what it is, as long as it's well-behaved like a sine function. If I take the sine function, or you know what, I'll take e to the x, that's easier. If I take e to the x, it looks like this, right? Then there is a way to approximate e to the x with what's called a power series. It's a bunch of powers of x being added up together forever. So I'll show you what I mean by that. Close this out. It's not the one I wanted. Here we go. Come on, I got to have e to the x in here. Where is it? There's log. I don't have e to the x. I might have passed up. Let me just go back. Well, maybe you'll just take my word for it on this one. Okay, so I want you to look at this red curve. Do y'all see this red curve here? Goes like this. Yes? And then it comes over here, does this, and then this right here is a vertical asymptote. This is the function 1 over 1 plus x to the 7th. And what I'm doing right now is I'm graphing here in black the constant 1 function. Is the constant 1 function a good approximation of this red curve? No, right? It's not. It actually sucks really bad as if I'm approximating. But now what I want you to do is watch what where is it? Instead of doing 1 here, I'm doing 1 minus x to the 7th plus x to the 14th. See this black curve right here? Is that a better approximation of the red one? Yes? Now watch, I'm going to keep adding stuff to this, and watch what happens to that black curve. Just keep your eye on the black curve there. Well, it's working real slow. These black ones, the dotted ones, are the ones like if I cut some of this off, but the black one is all of this right here. Do you kind of see that we can approximate this with this? Do y'all kind of see that there? Let me give you another one down here that might make you buy that a little more. This log one. Okay, there's a log function, right? There's a log function. It's been shifted around because it's 5 plus x on the inside. This is a log function. I'm approximating it right now with the constant function, and it's not a good approximation, is it? But if I go and approximate it with x over 5 plus log 5, that's a line with a slope to it. That's better than that flat line was, right? Still not that good. Now I'm approximating it with a quadratic. Is this quadratic even better? Sorry, that black one. Is that better than that dotted line we had before? Yes. Okay, if I go more, now there's a cubic. Open this up so you can see it. This one should work out pretty good. Watch what happens to the black curve. See how it's jumping back and forth? And see how every time it jumps, it's getting like on top, it's going further and further on top of that red one? Do y'all kind of see that? So what we learn later in chapter 8 is that if you take any continuous function, you can always approximate it with a list of a polynomial function. All right, this is a polynomial. It's a bunch of powers of x. It's called the power series representation of this function. And the power of that is that this is what your calculator does. This is what a computer does. When you type in log of 5 plus x into your calculator, or if you type in like log of 10.3, your calculator doesn't know anything but to plug 10.3 into all of this right here. That's what it does. And so, you know, it's how we were able to take these complicated functions and use computers to evaluate them. So we'll get more into that later. And that's pretty much the subject, all right? Finding antiderivatives, applications, series. We're done. Sound fun? Come on, lie to me. All right, so we're going to start with a quiz. So I need to know where you are as a class. I don't want you to use anything but yourself, all right? I don't want you breaking out your TI-89. I just want you to look at this and see what you can do, all right? There is, on the top, there's a thing that says code name. And then on the bottom it says name. Right now, I just want you to use a code name. Blackjack. Whatever the hell that says. Whatever you want your code name to be, so that nobody else in the class really knows who you are. Because after we're done, we're going to scramble them up, and we're going to pass them out, and you're going to grade them. All right? So unless you want people to know who you are and everything else, then you can put your name. I don't care. So please get working on this. I'm not going to give you a whole lot of time, all right? Maybe like 10, 15 minutes. It's 8 derivatives. I got all these emails. What should I study before I, come into your Cal 2 class? What should I do before I come in? Study derivatives. They're coming around. I want you working alone, okay? I don't want to know what you and your neighbor can do together on this. I want to know what you can do. No pressure. I'm not going to count this as a thing against you, okay?